Test number 9. All right. You were to define the terms. Hopefully you said something about solute being the smaller one. It's being dissolved. The solvent, you have more of it. It's doing the dissolving. Saturated solution is one that is maxed out. It's holding the maximum amount of solute. And concentration, something about the amount of a substance in a particular volume. Okay? Then number 2, hydrazine is dissolved in ethanol. Identify the solute and the solvent. Hydrazine is the solute and ethanol is the solvent. Number 3, fill in the blank. When water dissolves magnesium chloride, the water molecules that surround the magnesium ions orient themselves so their blank atoms are closest to the magnesium ions. And oxygen would be the answer there. Or you could have said well, go ahead.
I said positive.
Positive, hang on. Magnesium is positive, so it would have been the negative. Yes, sir. So you could have answered oxygen, or you could have answered the negative ion would be oriented towards the magnesium. Okay, number 4, if ammonium phosphate is dissolved in solution, how many ammonium ions found for every molecule that dissolves? It should be ammonium 3. There's 3 ammonium ions there. Did anybody put 4 there? Because you could have counted the other ion. Okay, just wondered if anybody did that. You had to read. In other words, if it just asked how many ions it broke into, the answer would have been 4. But it didn't. It asked how many ammonium ions it was broken into, and so your answer had to be 3 because of that. I just wondered if anybody misread it. Number 5, the solubility of a gas is given in a given solution is decreasing. If the pressure is constant, what happens to the temperature? It's increasing. Okay, number 6, you have a saturated solution of a solid in water. If you raise the temperature, will the solid come out of the solution? No. Will the solution still be saturated? No. Yes, ma'am.
What if I answered no, that it wasn't, that it didn't come out of the solution, but then I said it was still saturated?
Okay, then just take off half, please. Okay, given the following reaction, which of the compounds in the equation is insoluble in water? What you're looking for is what precipitates out. That would tell you it's insoluble in water. So if you go to the right-hand side in the products, you see that the magnesium hydroxide is a solid, and therefore that is actually what precipitated out. Okay, just see how he answered it. Yep, that was it. Okay, number 8, a solution of ammonium phosphate is mixed with a solution of ammonium nitrate. If the ammonium phosphate is insoluble in water, what is the reaction? So let me show you. Here, I'll use this one. Okay, so we have ammonium phosphate. This is a +1, this is a -3, so this gets the 3, this gets the 1. Always come out of here with black fingers. And this is aqueous because it tells us so, okay? So we're supposed to have that.
What if I didn't put those?
We'll get to that, okay? And then we have plus aluminum, which we know is a +3. Nitrate is a -1. And so we flip-flop these. So this is going to get the 3. And then we're producing aluminum phosphate. So that's a 1-to-1 relationship. And we are told that that is insoluble in water. So we know that's a solid. Even if you didn't put the aqueous on the other ones, let's say you didn't do all the aqueuses, you should at least have the solid on that one because that's the one that's precipitating out. Plus, and we have what's left. So we have the NH4, which we know is a +1. And we used that, and we used that, so we need NO3, which we know is a -1. And so we can just ditch those two, and it's a 1-to-1 relationship. And then we have to balance it, and to do that, there's 3 of these, so we're going to need 3 of these. That takes care of the 3 of these, 3 of these. So we're balanced. Oh, and shame on me, I didn't erase these. I know that messes some people up. So your answer should have looked something like that. You know what, if you didn't have aqueous the whole time, I don't care. But you needed to have solid on the one that was a solid, because it's specifically asking you about if it's precipitating out, right? Yes, ma'am.
What if we didn't put the solid, like if we didn't put?
Just take off 1 point. Okay? Okay, let's see. Number 9, how many grams of potassium chloride will you need to make 450 mils of 2.56 molar solution? If you need to see this, I will be happy to do it for you, but the answer is 85.7 grams of potassium chloride. Number 9, how many grams of potassium chloride will you need to make 450 mils of a 2.56 molar solution? Okay, so we remember that molarity equals moles per liter, and we want to make a 2.56 molar, big M, molar. You know what, I'll make it pointy so you can tell. How's that? Molar solution. And so we are given the volume in milliliters, so make sure that you convert that to liters. If you didn't, you are going to lose points. And then we need to know how many grams, because we need this, don't we? We're looking for the moles. And if we can find the moles, then we can find the grams. So you go ahead and multiply these two together, and that's going to give you moles, because this is moles per liter. So if you multiply this times this, it's going to give you moles. I don't know why. Oh, I do have it there, 1.15. I'm just going to make sure. 2.56 times 0.45. 1.15. Yep. 3 significant figures, so you end up with 1.15 moles, and that is of the potassium chloride, and you wanted to know how many grams that was, so you're just going to go like this, grams, 1 mole, you're going to add those up, and it's going to be 74.55 grams, and that's going to give you 85.7 grams of potassium chloride. So that's how you do number 9. Number 10, a chemist makes an aluminum sulfide according to the following reaction, and then you've got the reaction there. If he has an excess of ammonium sulfide and 125 mils of 1.51 molar solution of aluminum nitrate, how many grams of aluminum sulfide can be made? Okay, so we've got ... plus 2 aluminum nitrates yields aluminum sulfide plus, there we go. Okay, now let's put in what we have. We have an excess of aluminum sulfide. We have 125 mils of 1.51 molar solution of this. So we have, I'm going to put it into liters. And I have a 1.51 molar, which is the same thing as moles per liter. How many grams can be made? There's my given and my get to. I'm going to start where there's no question mark and go to where there is a question mark. I know to get from here to here, I have to go through moles. My moles is hidden right here, isn't it? So I'm going to go 1.51 moles of aluminum nitrate and per liter, because that's molarity, isn't it? Times line, and I'm going to multiply it by the liters. And that's going to give me my moles. So 0.189, 3 significant figures, because there's 3 back there. That gives me my moles of aluminum nitrate. Then I can go across the mole bridge. actually, then I could go to grams, couldn't I? So this is going to get a 2. This is going to get a 1. This is going to get a 1. The aluminum sulfide is 150.14. There we go. 3 significant figures. So it's going to be, I'm going to get out of your way in case you need to see it, 0. Whoops, I'm so sorry. Don't panic. 14.2 grams of aluminum sulfate. 3 significant figures. So that's number 10. Okay? And he tells you which movement is worth what in there. My hands are covered in the black stuff from doing the board. Number 12, what is the freezing point of a solution made by mixing 34.1 grams of sodium carbonate with 500 grams of water? Okay, so we want the freezing point. Depression. Freezing point of solution made of. Yeah, it's in water, so that's good. Negative I, K freezing molality. And so let's start. The negative I, we are looking at sodium, carbonate. 1, 2, 3 ions. So I is negative 3. Kf is given to us 1.86 degrees Celsius per mole. And the molality, we are given 34.1. Oh, we're given 34.1 grams of this. So I'm going to save myself some trouble. 34.1 grams of this times lined. The grams of that to the moles of that, 1 mole is 105.99 grams of that. And 3 significant figures, 0.322 moles. Now we are told that we are using 500 kilograms of water. So to find the molality, we're going to use the moles of the solute divided by the kilograms of the solvent, which is 500 grams, would be 0.5000 with the amount of significant figures there, kilograms. That will give us our molality. Our molality is 0.644 mole. 0.644 mole. And so keeping our 3 significant figures, our answer would come out at negative 3.59 degrees Celsius. So because we're working with water, that is the answer, because water's freezing point is 0, so that's already taken away from the freezing point. So that would be your answer. Okay, just checking. Don't want to steer you wrong. Suppose you have 2 solutions of the same molality. Which has the lowest freezing point? So they have the same molality. One of them is sodium chloride, and one of them is calcium chloride. The lower freezing point would be determined by which one has the most ions. Remember, because of this, if you have more ions, this is going to make a larger freezing point depression. This one has 3 ions, this one has 2, so this one is going to be the one that would give you the lowest freezing point. Number 14, a solution of C2H4O dissolved in water has a boiling point of 101.6 degrees Celsius. What is the molality of the solution? Well, you know that the boiling point elevation, I guess I should be putting these in here, equals IKBM. And we want to know the molality, so I'm going to solve for the molality. We know that the change in temperature, because this is in water, and water boils at 100 degrees, and this tells us that this boils at 101.6 degrees Celsius, so the change in temperature here is 1.6. So I can put in here 1.6 degrees Celsius. The I for C2H4O, that is a covalent compound. There are no ions in there, so I is 1. And then the Kb is 0.512 degrees Celsius per mole. So with that in mind, you have to have an answer and two significant figures, so your molality is 3.1 mole. And that would be your answer.
But I don't have that one.
Okay. Okay, because that one wasn't too bad. Yes?
If you wrote down the equation first, you get less points off.
If you wrote down the equation first,
You get less points off. That's what you said.
did you have trouble, you didn't come up with that answer?
No, I didn't, but I wrote the equation out first, and then
Sure, and did you not plug in the stuff that was there?
I did. I just did it wrong.
Okay, I'll give you half for it. So just take off half. If you wrote everything out and then it just came out wrong, take off half. And there were 3 points apiece, so they're actually worth closer to 4 points apiece. So just take off 2 points.